I'm going to go ahead now and switch gears and tee it up for the next speaker here. Our next speaker is Ryan Nicholson, and Ryan is the author of the SANS SEC 488 Cloud Security Essentials class, as well as an instructor for the SEC 530 Defensible Security Architecture and Engineering class. Now, with that, I'm going to turn it over here now to Ryan to talk about moving operations to the cloud.
There we go. Okay, I got my microphone now. So good morning, US. Good afternoon, evening, early morning, wherever else you are coming from when you're tuning into this presentation here. So my talk is titled Moving Operations to the Cloud. And the reason I put this slide deck together in the first place some months ago was I wish I had this kind of talk when I was working in my previous position, to where we were instructed, we're moving to the cloud, right? We have any new application that we're going to be spinning up, we're going to be moving out of our on-premise data center into a particular cloud environment or cloud environments. In our situation, we were, multi-cloud rather early on. So this talk steps through some of the, and it's for the type of folks that are facing similar situations, to where I've got this on-premise thing, this application, for example, that I'm running on-premise. What are the gotchas? What are the things I need to be looking out for? And from both an operations perspective, as well as a security team's perspective, of course, me being a diehard defender, that's always in the back of my mind when I use this new technology. What are those gotchas? Where am I losing control? Or even better yet, where can these new cloud services help me do my job much more efficiently here? So here's the agenda that we're looking at for this particular talk. First, I'm going to really briefly, because I only have 35 minutes or so buckle up. There's a number of slides here. First, briefly introduce myself and my background. I then talk through a couple different topics here, like first of all, moving to the cloud. Why are we moving to the cloud? And what does that look like? Using a case study, which is our next section that I'll talk through. We have a certain case study which may may hit home for a lot of you, moving your initial first web application, in this case, over to a cloud environment, what that would look like. And then, of course, being an AWS sponsored event here, AWS services that can help you along the way. And again, I've used several of these services way back when I was trying to move things into a cloud environment. So plenty to talk about here. Learn from my experience at this point. And then any concluding thoughts that I have just in general as it relates to cloud technology and moving your operations out to the cloud. So really briefly, as I said, just a little bit about me. As of May of this year, middle of COVID, I became a SANS certified instructor, which it's the crowning achievement of my career thus far. It's a very rigorous process. I'm very proud of myself and I'm very proud of SANS for putting their faith in me and coining me a SANS certified instructor. Also co-author, sole author of SEC 488 with the new version coming out at the Cyber Defense Initiative just next week. So we have a brand new version of that course coming out. Very excited about that. So if I'm going to, of course, hint at any courses, a lot of this material, as you're going to see coming up, is featured in SEC 488 as well, and a host of other topics as we talk through Cloud Security Essentials. Day job, I work for SANS as well. As you can see, I'm kind of all in with SANS at this point. It's my day job. I'm an instructor. I'm an author. It's a little bit of background. Again, just love getting certifications. I can't seem to stop. I've got a little bit of a problem, I would say. Also a recovering, and for some of those I've noticed were in the, based on the questions I saw at the last talk, some of you are in GovCloud. Well, I may have some things to say coming up about GovCloud. That's where my first cloud experience actually stemmed from. And just a little trivial thing about me, I'm also a guitarist, so just throwing that out there. Any fellow guitarists in the room, good stuff. All right, so into the meat of the talk here. Can't spend too much time talking about myself. So let's first dabble in what this talk is all about, and that is we are moving to the cloud. Many of our organizations are already there. Many are dabbling in it. So what do we need to know about it, and why are we moving there in the first place? A lot of the cloud vendors out there, AWS, Azure, Google, you name it, right? They're going to be touting, come to our lovely our lovely infrastructure here. We provide you scalability, failover, very high uptimes, rapid provisioning, and for the CFOs in the room, or for the company, I should say, pay for only what you need. So a lot of this does ring very, very true here, because doing a lot of these things that you're seeing on the slide on premise was predominantly very, very expensive to pull off. So now cloud natively supports a lot of these things for you. If I want to have redundant systems, a lot of times it's, toggle the correct switch and it magically happens behind the scenes for you. Now there is a lot going on, of course, that the cloud vendor is doing for you, but it's a much easier barrier to entry when you want to start doing these things that you're seeing on the slide here. However, though, a lot of the initial moves into the cloud environments are typically, it could be regulation, like in my case, where it was, you are moving to the cloud, no ifs, ands, or buts. Just do it, make it happen. And those initial moves to the cloud often entail taking what you have in an on-premise environment and just duplicating that out in the cloud. And then, as you learn more about that cloud vendor environment, start using some of those cloud native services to help you along the way. So in the example here, we might have 3 servers on premise that we're using now. We'll just recreate that in the cloud. Again, that's a very common initial move for those that aren't as experienced in the cloud world, but we'll talk through several services that could be leveraged to ease that shift into the cloud, not just from an operations perspective, but also from the security team's perspective, of course. Okay, so the first step often, at least from the operations perspective, like I said, it's typically going to be where I'm going to take, if I have 2 web servers and a database server, I'll typically migrate that over if I don't know what these other cloud services at my disposal are. But you may, of course, want to do the research if you're an operations person. How can I make my job much easier here? So if I'm, say, moving a web server over into this environment, what do I have at my disposal? Do I just want to spin up a virtual machine and manage the operating system, manage the application code itself? Do I want to do all that, or do I want to look at some kind of cloud service to do this for me? And there are several options out there, again, depending on the vendor, and most vendors do support these as well. First being, of course, well, I could go with this new industry buzzword now, serverless. The first example that I have is cloud storage. Cloud storage is often, it often makes the news, when there's a breach of a cloud environment. It's often, S3 buckets, right? We all have heard the negative connotation behind S3 buckets, and you'll see metrics out there like 7% of S3 buckets are public. Well, some of those, yes, that's by accident, but some of these are going to be on purpose as well when you start spinning up static websites now using cloud storage. Your major vendors are giving you this ability to do this now. So what I mean by a static web server, that if you're just serving simple files like HTML files, CSS files, JavaScript files, things that aren't going to be running on a web server, you're just serving files, you can easily do that now with cloud storage. So if you put yourselves in the shoes of those operators, or if you are on the operations team listening to this talk, that's a huge win for you all. Because again, no operating system to manage, no application to manage. I'm literally just pushing my files out to an S3 bucket and luring my users there instead of my web server. For any dynamic web code now, again, we can think outside the box a little bit and move towards functions, which are, like in AWS's case, Lambda, right? You can have a Lambda function. Instead of your web server running that dynamic code on the server side, you can now have a Lambda function do that for you now. So really cool stuff here when we're talking about moving outside of just running something in an instance. Databases, of course, managed databases are a huge win. My pain points from way back in the day when I was a systems administrator, my least favorite thing, was actually 2 of them, Active Directory and database servers. So the fact that managed database services are out there now with your various cloud vendors is a huge win for that operations team as well, I'm assuming, right? Because again, unless you're a special kind of person that loves managing operating systems and database software, it'd be a breath of fresh air moving to this managed database environment in this case. But we're going to start talking about a little bit more from the operations perspective, but then pivot over to security really quickly here. So the last bit from the operations side that I really want to focus in on is network appliances. Data centers are just loaded and loaded and loaded with network appliances from both a security perspective and just moving packets throughout the network. But again, now we're moving out to a cloud vendor, a cloud hosted environment that manages a lot of this underlying networking for us. We have a little bit of influence, of course. We can set up route tables, we can set up security groups, which is the layer 3 and 4 filtering and so on. But a lot of these things that we typically manage and these very expensive products that we manage on premise typically will have some kind of cloud service variant out there, which again can save us money, can save us time in operations if used appropriately. That's why I have the little star there with the no more expensive network appliances, because these services can get a bit out of hand if you're not careful. If you're just using the largest instance available all the time, no matter what, whether you need it or not, that can lead to some costs that may actually dwarf what you were paying on premise. So in a perfect world with a good steward of your cloud services, you should be able to save some money in this case as well. But this chart breaks down some of those commonly used on-premise appliances that you may have or services that you may have, and then the cloud services as they relate in AWS in this case. So you can see some of the common offenders here, like network load balancers. Of course, there's going to be a service for that because of the elasticity and availability that the cloud vendors provide to you. They, of course, would have to give you the option to load balance this traffic and use this appropriately. Web application firewalls, AWS Shield is available. Layer 3 and 4 filtering, which I'll talk a little bit more. I'll hold off on that, but we can see some examples here: security groups, network ACLs. And a late breaking one, I actually wrote a blog post about this just a week or so ago, the AWS Network Firewall. Now we're starting to see some things that talks above and beyond layer 4, but I'll have more to talk about when it comes to some of these services coming up here very shortly. All right, there we go. So I'm going to first present like a case study, which may be very common to what, again, you're moving out to your new cloud environments. And the little example that I'm going to show here is a very, very simplistic network diagram. I don't even want to call this a network diagram, just a really high level diagram showing the before and the after picture, going from an on-premise environment for this particular application out into a cloud environment. And here we see, again, a typical network layout where we'll have a demilitarized zone or a DMZ where web services, public-facing web services often sit, or they better sit, right? You don't want this in your internal network, of course. If they're compromised, they're already in the belly of the beast here. But this is the typical layout you'll see of these web servers in the DMZ, database backend servers in some kind of other screen subnet somewhere deeper within the organization. And those are the two components that we're going to lift and shift, if you will, and take those out of this environment and put into the cloud environment. But notice some of the security products that we have in place here. We likely have a next generation firewall. If you're playing buzzword bingo, by the way, you're going to have blackout here very shortly. But we have a next gen firewall doing a lot of that application layer inspection, layer 3 and 4 inspection as well, ensuring it's proper web traffic destined for our web servers and so on, right? We also see that we have some intrusion detection systems here as well, looking for known malice, if you will, based upon signatures that it had seen in the past. So, and then of course, within the internal LAN, we're going to have possibly even more firewalls, maybe a database firewall there as well, and other host-based protections and network-based protections may be included in the internal LAN environment. But when we shift gears now and move out to AWS in this case, notice that the web and database servers are now sitting in some way, shape, or form out in the AWS infrastructure now, out in that cloud account that we're currently managing. So if you look where our lovely attacker in the hoodie here, you can always pick out attackers, by the way, when they're wearing hoodies, but they're not going through our internal LAN at all anymore, unless we get some really creative network engineers to try to force them through our security appliances that we're using on premise. Most organizations are not doing that. They're directly going to be accessing these services. So we're losing a lot of the capabilities that we had before, at least right now. The next gen firewall really isn't doing anything. You could argue if we have internal users that are accessing our web server and attacking it, then yeah, it would see that. Same goes for the IDS that we have on premise. It's not going to see this traffic. So as of right now, if we just spun up an instance to serve our web content and we have this managed database service, we're reliant solely upon what the cloud provider gives us here, unless we start to add on some more services and some more functionality, which we will be getting to very quickly here. So first, though, we got to talk about what certain threats may be coming our way, targeting our cloud-based now web server and database server. Now, I said cloud-based, but it really doesn't matter at this point because these same threats tend to exist whether you're in the cloud or not in the cloud. Yes, there's going to be some nuances to cloud. There's going to be a larger threat landscape out there, but for all intents and purposes for our little discussion here, we'll focus on some of the more common web-based attacks, like an attacker trying to discover known vulnerable web pages. Anytime you see a brand new WordPress vulnerability out there, for example, and if you're hosting something, hosting some web content, you pay attention to our logs, I guarantee you within a matter of minutes, you're going to see some folks looking for that vulnerability, looking for that page that introduced that vulnerability or that plugin, for example. So they're going to be looking for those sorts of things. Any pages with authentication, of course, they're going to be trying to look for. And if they discover those, they may try to brute force or use a wordless attack to try to break into that, that secret area of your web server or that sensitive area of your web server. And of course, any other OWASP top 10, OWASP being the Open Web Application Security Project, any of their top 10 vulnerabilities, SQL injection, command injection, cross-site scripting, you name it, right? Those are the types of threats that may be coming your way if you're hosting, whether you're in the cloud or on-premise. So now that we're putting these services outside the purview of our on-premise security devices, what do we do now? So we're going to talk through some of these new challenges because we're going to be losing some things from on-premise as well, not just the security appliances, but like our log data. Where's that relevant log data that we can see an attack coming or seeing an attack in progress and put a stop to it? So where are these logs now? How can my analysts now run down an attack, or my forensics team figure out what the heck happened after a compromise? So there's a lot of challenges that we have to address, which again, we will, but I just want to lay the groundwork here. Our network security monitoring tools, again, we have to think of some solution around this because we don't have that IDS anymore on premise to support this cloud workload. What happens with our SIEM? How do we integrate, once we get this data now, how do we get this data to our SIEM? And finally, which is great stuff coming in a newer course with SANS, SEC 541, there's going to be just some discussion on automating responses to an attack. So how can we do that? What are some techniques we can put into play to automate, to try to take the human out of the response, to get much more real-time automation to these attacks, put the stop to the attack, stop the attacker in their tracks to the best of our ability by using some cloud technology to our advantage here. So the first bit, though, is there's always an additional threat when it comes to hosting things in anywhere, right? Because we were doing this on premise. When we're supporting our customers or our clients with web technology, for example, we want that web technology to be available to them. We could be losing some business. So with scalability and redundancy in the cloud environment space, we have to account for that there as well. So that's something we, of course, need to research and make sure is available because stuff happens, right? A web server could potentially go offline. And if we don't have scalability and redundancy considered in that case, where you can fail over to, say, another region or another availability zone in the event that, yes, even the cloud vendors do have outages, we need to be prepared for that as well when we start deploying this thing. So it's not just lifting that one web server and putting it in the cloud. We need to account for any potential outages from either our perspective or the cloud provider's perspective as well. This is, again, where serverless may shine because these serverless technologies have this built in by default because the cloud vendors are doing this to them. So they're eating their own dog food, if you will. They're trying to tell you, you need to be doing this scalability and redundancy. We're trying to lure you here because we offer this solution. So they're going to be doing that themselves because they have a reputation to uphold as well. They need to have their services available. So, use their blood, sweat, and tears to your advantage here as well, if that's something that interests you. But we're going to cover more of these other security caveats here in a second, once we, again, talk about the database side of the house. Database needs their own scalability and redundancy also. So moving to these cloud native services would be a huge win. And again, my pain points have always been with databases, managing the database itself, the database cluster, the operating system for the database. So again, pushing as much of that to the cloud vendor. If you trust them to take care of it for you, then certainly wouldn't be a bad thing here as well. And a lot of the things that we've talked about with scalability and redundancy are simple, make the right selection when deploying the service and you should be good to go here. All right, so now shifting gears to the some more security discussion here and talking about layer 3 and 4 protection. So we have a couple different options for us and one rather new one that I'll talk about on the next slide coming up here to help limit the exposure of our systems to would-be adversaries. It never fails that during SEC 488, when I'm teaching that, or even when I teach SEC 530 and that defensible security architecture course, we talk about, Shodan. Shodan is a great tool to self-assess, right? You can put in your company name or put in your IP space, and what Shodan is doing on a regular basis is just scanning the internet, trying to grab banners from listening services and present some kind of information about what it's finding. Now, again, attackers love using this service as well to try to discover if there's a new flaw with this particular version of this software. They'll use Shodan to try to discover, use their work instead of scanning themselves. Consult Shodan and say, show me all the Apache version 2.4. whatever, right? There may be a flaw with this. So you don't want to be exposed that way. So limiting the access to your environment, if it doesn't need to be made, certainly a huge win there. But it never fails when I teach this class and I want to bring up something like Elasticsearch, for example. See how many Elasticsearch databases are out there that are being hosted and facing the public internet, which is typically a bad idea. It never fails that the top 4 or 5 vendors that show up are all cloud vendors. Now, that's not the cloud vendor. That's customers of that cloud environment. So that tells me that a lot of consumers in these spaces aren't paying close enough attention to things like security groups, network ACLs, even their own host-based firewalls to limit traffic to these sensitive services. And we need to be doing this. We definitely need to be doing this because they're going to discover these services very rapidly. If the attacker doesn't, Shodan will within a matter of days, and it will be searchable now. So all of your dirty laundry will be out there for those to find. So controlling at the very least layer 3 and 4 traffic is a huge win here. And I give an honorable mention here to VPC endpoints. What those are essentially used for. If you have an instance within your virtual private cloud, whether it be an AWS, Google, Azure, you name it, right? Many of the big 3 vendors at the very least offer this type of solution. And they need to talk with another cloud service. That typically could go over the public internet. If you want to limit that and force them to use the backbone network of that cloud provider, you can look into something like VPC endpoints, which it literally puts a private endpoint inside your VPC. So now your instance or virtual machine will talk directly with that service over the backbone network instead of the public internet. So for more sensitive workloads, would certainly be a very good idea to implement something like that. All right, but beyond layer 3 and 4, this is where, again, it's perfect timing for this forum here. AWS brought out their network firewall offering. This was a breath of fresh air to me, because typically if you want to do some very creative things with application inspection, yeah, you have like your WAF, for example, but if you've got some very unique applications and unique payloads traversing through your network and you want to inspect or block based upon those payloads, you had to shove that data through another instance that was acting as a network appliance. But now we see some more cloud native services giving us this capability where we can now start to look beyond layer 4, looking at the payload itself and making some kind of determination that way. So this network firewall gives us the ability to block traffic based upon a few different things, as you see here. The source IP and or port, destination IP and or port, as well as the protocol. They call that the 5 tuple. So you can create now more robust firewall rules to block or permit traffic based upon those 5 details there. Also, though, you can block based upon or allow based upon domain names, which is very unique here also. Again, looking more at the layer 7 or the application layer here. And then the one that really hit home for me that I loved seeing this, now I can start putting some of my IPS, my intrusion prevention system rules into the network firewall. And now as it's seeing this payload traversing, I can, again, use these Suricata rules to block or allow that traffic. That's extremely powerful from a cloud native service. I don't have to rely upon, again, shoving my traffic through an instance running these tools. It's natively able to be used within AWS, which is very, very cool. However, again, through creation of my blog, I realized very quickly that does require some re-engineering of my environment. It's not just turn on the network firewall and it'll handle it from here. You do have to re-engineer your traffic flows and traffic patterns within the VPC itself. So some routing table updates, more isolation using subnets and so on need to come into play. So you do have to put on your engineering hat and your architect hat to make this, this network firewall work for you in your AWS environment. But really, really cool stuff. I was glad when I saw that, which prompted that blog post. All right, so what about the web payload now? We saw some IPS capability in that network firewall, but we can take it a step further and start deploying what's known as a web application firewall, or a WAF. Again, we can certainly do that by putting another instance in front of our web instance that we're currently running at this point, or yet again, we see another cloud service. In AWS's case, it's going to be AWS WAF. And when we're configuring these WAFs, we have a couple different approaches we can take. The one that's most often used, to be quite honest, is the deny list approach, where we have known bad. A lot of the cloud WAFs can ingest rules. Another OWASP project is their core rule set. They have what looks like known bad. You can ingest these rule sets. If the attack comes through this WAF system and it matches one of these rules, it's going to block that traffic. But attackers can, of course, evade that. If they're using an unknown technique or a new technique that doesn't quite match that rule, it'll be allowed to be passed on through. The more difficult yet more robust way to do this, however, would be to create an allow list approach. This is where we have, here's a rule set for all the known good traffic that's expected to go to my backend web server. Anything that doesn't match these rules, block this. So you can imagine that involves a really good relationship with your web developers and a lot of watching the network traffic and knowing what that normal happens to look like in your environment before you can start implementing these allow lists. It is a lot of work up front, but much more robust, blocking that traffic, that bad traffic from reaching your web application. All right. So now we've got all these great services, a couple, and this is just the tip of the iceberg, by the way. I only had 35 minutes. I can't cover everything you can do in AWS from a security perspective. But now that we've got a couple unique components running in our environment, we need to, of course, monitor this. So this data is residing everywhere. We have data on our web servers themselves. So a lot of the GET requests, the posts, any errors that happen, and of course, the underlying operating system logs all on that web server. We could have some data in AWS CloudWatch. We could have data pushed to AWS S3, depending on how our services are configured to push their log files. So how do we wrangle this data? You know, the worst possible solution for an analyst, so for any analysts listening, I'm preaching to the choir here, the worst thing you can do to your analysts is have them have to dig in through multiple dashboards. So if you're multi-cloud, for example, I have on-premise systems. So I might have a SIEM on-premise. I have Azure, for example. You know, I did say that dirty word during this talk for those that are AWS fans. So you might have a presence in Azure to where now I have all my data there. I have to then pivot to. I have AWS data. I have maybe some SaaS provider data. A much better thing for your analysts, of course, would be to wrangle all that data and push it down to one, again, buzzword bingo here, and I hate using this word, single pane of glass. So they can do their day job all in one platform. So there are, of course, going to be ways that we'll talk through to make this happen. Okay. So as I said, a lot of these services can send their data in AWS to CloudWatch and or S3. So from there, though, what you can do is move this data to a more appropriate place if that's not the ultimate destination for that data. Not to say you can't go through CloudWatch to run down an attack. You most certainly can, but your analysts, again, may appreciate the data being in one place. So how do I get it there? One additional service that you could subscribe to is AWS Kinesis Data Firehose to push that to your third-party product or to some other product, if you will, to get that data there. Also, another key component to CloudWatch, now we're kind of sticking with the CloudWatch monitoring here, is yes, I'm sending all my data to CloudWatch, but from there I can have CloudWatch generate what's called an alert. So if I see a bunch of log data, that's great, but I may be able to correlate certain logs or say, if I'm seeing so many logs in a certain amount of time, generate an alert. I may have some malice happening within my environment. And then from there, this is where we can start to revisit some automation techniques, where if an alert is generated, you know, what else can I do in my cloud environment? I could kick off, say, a Lambda function. So just a really quick case study or an example, I'll say. So let's say you have a user that's just, logging, someone's attempting to log in as your AWS user over and over and over and over again. A bunch of denies are happening. That's, of course, going to be captured in CloudTrail, which can send that data over to CloudWatch. So I can set up an alert looking for that, saying, yep, looks like someone's brute forcing or running a dictionary attack against my AWS user account. But what happens if after a long series of denies happen and then we have that eventual permit? It looks like that account was successfully logged into, that brute force or dictionary attack was successful. So I can generate some kind of automated response to that to say, if I see a bunch of failures followed by a success within a finite amount of time, I'm going to consider that breached. I'll do something like kick off a Lambda function, which will remove permissions from that user. So yes, they're in my cloud account, but all the permissions were stripped. So we did some kind of automated response at that point. So you can be very creative. The sky's the limit when it comes to the automated responses within these cloud vendor environments, which is great stuff. Okay. So one of the remaining gaps, though, we have here, again, I left networking ever so slightly, but now we're going to come back to networking really quickly because the gap that we currently have is, yes, we're doing a lot of prevention at this point. We have the network firewall doing some detection and prevention for us, but what about the rest? What if, all of our defenses are evaded, the service didn't catch the would-be attacker breaking into our environment? How can I get even more insight into that network traffic that's happening within my environment? Early on with cloud vendors, that wasn't a possibility, where you just simply couldn't see that payload until it arrived at the host itself. And then you have to do some kind of monitoring at the host, which could get very expensive very quickly. Doing monitoring on every single instance in your environment, it's a lot of software to run. That's a lot of agents. That's a lot of management. But now we have things like VPC traffic mirroring, to where we can get back or get closer to those on-premise IDSs where we're sniffing traffic right off the wire. Now, there, of course, going to be some setup involved here. So you have to configure a couple different things. One of those things being a mirror source, which is essentially, what do you want to mirror in your environment? What do you want to capture the traffic from? Now, this is going to be something that's awesome in the cloud, which we couldn't selectively do nearly as easily on premise. Because typically we'd have like a span port on a switch and we'd pick which switch ports we want to monitor. But in the cloud, it's as simple as saying, I want this elastic network interface. I want this to be my mirror source. So it could be a critical system, could be all your systems. It's really up to you what you want to choose as your source. But on the flip side here, you have to also choose, well, where am I going to send this data? Where is this data going to be replicated to? That could be another instance in your environment acting as an intrusion detection system. So really cool stuff to be able to get that network payload now and run those network security monitoring tools in our environments. Now, of course, we got to keep our servers up to date as well. So just I know this is kind of a no-brainer nowadays, to where we're moving into the cloud. We get things automatically deployed for us using, like with our auto scaling, for example, it's based off of a known good golden image, but we got to keep these things up to date. So a couple different techniques of doing that. Yes, you could do a rolling redeploy of systems, which is pretty easy to do in the cloud. So if you update your gold image, for example, to be more up to date, have more embedded updates or hardened security settings, you can do a rolling redeploy of those systems. You can subscribe to other services that the vendors provide you as well. In AWS's case, that's their patch manager service, which is within Systems Manager. So again, just the big thing I wanted to mention here is, because you're in cloud, you still got to keep things up to date if you're managing the systems or the applications yourselves. All right. And the final piece, I know I'm not running long, but I'm getting really, really close to where I wanted to cut off and take some questions. IAM. So the reason I put this at the very end is because all that stuff that I talked about is all well and good, but if you're not handling IAM, and there's a reason why we make this an entire day, the first day of Sec 488, if you're not doing IAM properly, it's game over, right? If you lose your root account to an attacker, if you lose an administrator account to an attacker, it is essentially game over. All of those prevention and detection mechanisms you put into place can easily be stripped away. They can get at anything within your cloud account. So super, super important that IAM is first and foremost taken care of and regularly audited, and just making sure that you've done least privilege to the best of your ability in your cloud environments, or it again could be game over very quickly. And there are some other third-party tools that can help out with the management of IAM, such as cloud access security brokers. They can look at things like user behavior and at least tip you off to say, we've got some suspicious activity within your cloud account. So it wouldn't hurt to have a second set of eyes here, right, to do some more automated analysis of your environment. All right, so in conclusion, I talked about a lot of things very, very, very quickly. Welcome to Sec 488, by the way. We do the same kind of thing in that course where we're just moving from topic to topic to topic. There's so much to talk about in cloud. It's not as simple as just saying, yep, point your systems here, deploy them here, call it a day. There's so many things to be looking out for. And I just started to scratch the surface in this talk here. So hopefully you got a lot out of this. The things I want to are highlighted here on the slide or bolded on the slide. Do the research. Use the best service that you possibly can. That's something that's really harped on whenever you're going for any AWS certification, for example. They really, really want you to be paying close attention to new services, because stuff changes very rapidly in the cloud. You may be doing something that's not the best for your organization. So do the research. If a solution doesn't exist for you, the beauty of the cloud is their APIs, their application programming interfaces. If a tool doesn't exist for you, write the tool, right? If you have the capability or the team to do that, they make it easy. They make it easier, we'll just say in this case. And we definitely need to be doing monitoring in cloud environments, not just from the networking perspective, but again, that IAM is super, super important to pay close attention to. All right. So with that, I think the last thing I have is if you want more of that great stuff, again, tip of the iceberg, we've got several courses throughout the cloud curriculum, as I'm sure Frank is going to talk about throughout the sessions here. So again, I'm not going to tell you which one to take, but I've got, of course, my preference here. And there's some contact information for me. Reach out on Slack if you need more or want more. I'll be taking some questions now, as well as in the Slack channel after I'm done here. So I'll turn it back over to Frank.
Yeah, Ryan, awesome presentation. We do have quite a number of questions, so definitely some of them will need to be taken in the Slack channel here, but let's see how far we get here. You talked about this a little bit already, but any recommendations, other recommendations on open source tools for network security monitoring in AWS in particular?
Not to my knowledge. I mean, normally what we were using in my last environment was your typical third-party vendors that do a lot of like SIEM work, for example. Not going to name the vendor, but they have a lot of great integrations into those cloud environments where you can pull that data down and do the analysis within the SIEM that you already have. So that's, of course, going to be one option. And there are plenty of auditing tools that audit the cloud environments as well out there. Just again, off the top of my head, I don't have too many to really speak to. Again, just in my experience. So yeah, nothing to really add to that other than saying that there's plenty of open source tools out there that can give you some additional insight into those cloud environments.
Mm-hmm. And a little bit more of a detailed question here is, do you believe the IPS can protect web servers from the more prevalent layer 4 and above attacks versus the more specific focused WAF solutions that you're talking about? What do you recommend?
So they're I don't want to call them one and the same. WAF, I would consider like a more specialized IPS, where they typically will have rules that are very tailored to web applications themselves. Not to say, but IPSs can do the same type of thing, because at the end of the day, they're just looking at the payload. They're just looking at it a little bit differently, where with an IPS, they're looking at raw bytes, right? In a lot of cases, where they're not doing that deep of decoding that they may be doing, that a WAF may be doing. Because data can be sent in multiple formats. It can be compressed. It could be in base64 encoded, to where a WAF will be able to strip all that away and make more informed decisions based upon that. Not to say IPSs can't do that, but it does take additional tuning to make that happen on the IPS side of the house.
Mm-hmm, mm-hmm. Now, you were talking about monitoring, and is there a similar AWS service to Azure Sentinel?
For Azure Sentinel, I'm not aware of one, but luckily we do have some AWS personnel on the call here. I was going to say Security Hub, but I don't believe so. That's more of a checking in on configurations and compliance checks across your multiple AWS services. From Sentinel, though, my understanding, of course, is going to be more of a Microsoft like SIEM type of solution that you can use within Azure. I'm not aware of one in AWS, but luckily we have the folks on the call here.
Yeah, exactly. I would like to hear the AWS folks chime in here on Slack, but with Azure Sentinel, like you said, that's a SIEM. They also have SOAR functionality, and there's not exactly the like equivalent on, as far as I understand, on the AWS side. It would be more. You mentioned the Elastic Stack earlier, right? And using the Elastic Stack in AWS would probably be similar.
Yep.
Now, in terms of logs, right, related to monitoring here, and we'll just do another one or two questions here. What do you think is the most efficient way to pull logs from AWS into your on-prem SIEM? How would you go about doing that?
Okay, so my solution that I'm most familiar with that we had used was sending everything that we could to CloudWatch, and then from there using Kinesis Data Firehose to send that off to our on-premise environment. Of course, we'd have to have the networking in place and the reachability for that, but that's the approach that we took, and I would recommend as well.
Mm-hmm, mm-hmm. Great. Now you mentioned there's a number of questions related to the new network firewall. How is the firewall different from the WAF? How is that compared to the firewall manager? How did all of these things with the term firewall in them differ, right? And how do they work together?
Right, it's a big question. So that's why I led into the story of, before we had to like shove all of our network data through an instance acting as our next gen firewall, to where the network firewall services kind of, it doesn't do that for you. Because like I said, you have to re-engineer, you have to reroute your data through very similarly to how you would have done before. But it gives you a little more extended capability above and beyond what security groups and those network ACLs do, all in one nice package here between two separate subnets at this point. So it's just looking a little bit more at the layer 3 and 4 data, as well as giving domain-based blocks and that Suricata IPS-based blocks as well. So
great.
to compare to the other ones, it's hard. It's apples and oranges, I would say.
We do have a question on serverless, but I'm going to table that just so everybody here listening knows. We've got another talk coming up here in about a hour and a half or so, where Brandon is going to be talking all about serverless and serverless security. But Ryan, the last question that I'll end on here is that if you are moving to the cloud for the first time, or you're expanding the usage of the cloud, you've got your customer that you're working with, whether that be you as a consultant providing service to a customer or an internal business unit. What is the first thing that you would recommend? What else do you need to know in terms of kind of getting this migration planned out and on the move?
Yeah. So again, speaking from experience, what we would typically do is take whatever we're trying to transition into the cloud, or whatever application we want to build, just kind of break it into its small pieces and see, what are all the components to my application? Does the cloud have an equivalent piece of that? Can I start to leverage some of those cloud offerings to give those quick wins that we talked about before, like the scalability, redundancy, elasticity, all that good stuff? So breaking the application apart, seeing where I can start to leverage those moving parts within the cloud environment is really the first step to really understand your application, how it operates, and how we can translate that over into the cloud world.
Awesome. Hey, well, Ryan, great presentation. Everybody, let's give him a virtual round of applause. The other questions we'll have to take offline here or online in Slack.